Good morning, all. I am Professor Swam Reddy from SR University, Department of Mathematics. Today, we are going to discuss the applications of Laplace transform. In previous lectures, we have discussed the different forms of Laplace transform, right? Laplace transform by differential equations, Laplace transform by differentiation, integrals, and Laplace transform division by s, multiplication by s, right? So we have discussed elaborately in 1 to 7 lectures. Now in this lecture, the applications of Laplace transform, that is to the ordinary differential equation, or the solutions of ordinary differential equation by Laplace transform method. So how you solve using Laplace transform the ordinary differential equation? First of all, what is the solution of ordinary differential equation? Suppose, for example, the differential equation is like this: d square y by dx square plus 2 dy by dx plus 4y equal to some e power x. So solve. So how you solve? Normally the differential equations first write in operator form: d square plus 2d 4d or 2d plus 4 into y equal to first 0, right? What is d here? Capital D is equal d by dx, differential operator. Next, write auxiliary equation. So what is the auxiliary equation? Is nothing but algebraic equation: m square plus 2m plus 4 equal to 0. Now solve for roots. Then we will get roots m is equal plus or minus something. Then write complementary function y is equal to. So this is a complementary function for the homogeneous differential equations. If equal to 0 homogeneous, suppose equal to e power x, for e power x you you should calculate particular integral. That e power x, there are different cases to finding a particular integral. There are many cases. According to that cases, find a particular integral. Then finally the general solution of differential equation is y is equal complementary function cf plus pi, particular integral. This is the general solution of the given differential equation, ordinary differential equation, right? But if you apply the Laplace transform to the ordinary differential equation, no need to calculation of these complementary function and particular integrals, right? And adding of complementary function plus particular integral. Just to apply the Laplace transform at a given initial conditions, it will give direct solution. No need to calculate these complementary function particular integral. How? Just you see here. That is the advantage of Laplace transform, right? The Laplace transform can be used to solve the differential equation with constant coefficients only. The advantage of Laplace transform is particular solution can be obtained for the given initial conditions without obtaining the general solution. That is the advantage. So what is the working procedure? Here the working procedure is first write down the given differential equation, right? And apply Laplace transform on both sides to the given differential equation. And use the given initial conditions. Substitute the initial conditions. And rearrange the equations, right? And rearrange means just simplify for the solution. Next, finally, you should take inverse Laplace transform on both sides. Then it will give the solution. First, write the given equation in proper way and apply Laplace transform both sides and apply substitute initial conditions and simplify and finally apply inverse Laplace transform. These are steps to find the solution of ordinary differential equation using Laplace transforms. Just you go to this. You know the Laplace transform derivatives. Already we discussed in previous lectures. The Laplace transform first order derivative is s into Laplace transform f of t minus f of 0. Uh, or you may write this s into Laplace transform f of t is f bar of s, or right, f bar of s f of 0. Similarly, the second order derivative is s square into f bar of s minus s into f of 0 minus f dash of 0, second order derivative. Why we are introducing here Laplace transform derivatives? This is for this is required for the solve the ordinary differential equation. Laplace transform derivatives is required here. Just you see here is the third order derivative. These formulas are now useful to solve the ordinary differential. The fourth order derivative. Third order derivative start with s cube f bar of s and s power decreases s square s and s power 0 here. Now here f bar of s square f of 0 f dash of 0 f double dash of 0 like that. So here f triple dash end with f double dash of 0. F fourth order derivative end with f triple dash. F nth order derivative end with n minus 1 derivative. Like that. Here n s power n minus 1, n minus 2, n minus 3 and so on s power 0. This is the Laplace transform derivatives. Now let's go to the example how you solve the differential equation using Laplace transform. Solve the following differential equation by Laplace transform method. Here d square x by dt square minus 4 dx by dt minus 12x equal to e to the power of t. Where the initial conditions x of 0 means x of t is equal 0 here is 1, x dash at t is equal 0 is minus 2. Now this differential equation, you can write this x double dash t minus 4 first derivative of t minus 12x of t equal to e to the power of t. So this is the given differential equation. Right? This can be written in the form of here x is a dependent variable and t is the independent variable. Right? Both sides taking inverse Laplace transform. Right? Sorry, not inverse Laplace transform. First, both sides take Laplace transform, not inverse Laplace transform. First Laplace transform, finally inverse Laplace transform. So Laplace transform of x of t is x bar of s. Laplace transform of x dash t is s into x bar of s minus x of 0. Right? Already we discussed in previous slide. Now. Laplace transform x double dash t is s square x bar of s into x of 0 minus x dash of 0. This is a second order derivative. Now here we apply this Laplace transform of this x double dash t is this one x double dash t. Next x of t. Next x of Laplace transform of this one. Laplace transform of x of t is x bar of s. X dash t is this, x double dash t is this. Just substitute. And the initial conditions x of 0 is 1. Apply. And x dash 0 is minus 2. Just you write down here and simplify. Here is s square x bar of s minus x, right? Minus s plus 2, 4x minus here initial condition is 1 and dual s by 1, 1 by s minus 3, right? Laplace transform this e to the power of 3t. Now this is x bar of s take out, x bar of s take out. So s square minus 4s minus 12. Here remaining terms minus s, right, plus 6. There is 6 here, minus 4 into minus 1 plus 4 here plus 2 plus 6 equal to 1 by s minus 3. Is it right? Now x bar of s square minus 4s minus 12 s to send this side. Minus s plus 6 sent to right side. So plus s here minus 6 by here 1 by s minus 3. Now next is solve for roots, right? So what are the roots here? S square minus 4s minus 12 equal to 0. What are the roots here? S square, right? 12. 6 2 ja 12, right? Or 3 4 ja 12 is 4 na. Here what do you write here? Plus here minus 4s na. 6 6s plus 2s minus 12 equal to 0. Is it right? Minus 6 plus 2 is minus 4. Minus 6 into plus 2 is minus 12. So s common. S minus 6 here plus 2 common. S minus 6 is equal to 0. So s minus 6 and s plus 2 are roots. S minus 6, s plus 2 are roots. Now x bar of s is equal, send this side. This is x bar of s. Right? Now both sides taking inverse Laplace transform. Take inverse Laplace transform both sides. So inverse Laplace transform x bar of s and inverse Laplace transform this. So how you solve this inverse Laplace transform 1 by s plus 2 s minus 3 s minus 6 plus this is directly you know e to the power of minus 2t. It form like Laplace inverse Laplace transform s plus 2 is e to the power of minus 2. But this is we can't get. How you get the inverse Laplace transform this type of function? Split into partial fractions. Split into partial fractions. Just here a by s plus 2, b by s minus 3, c by s minus 6. Now take LCM and solve and put s is equal to 3 and s is equal to 6 and obtain a, b, c values. Then we get a is equal to 1 by 40, b is equal to minus 1 by 15, c is equal to 1 by 20. Already we did many problems on splitting into partial fractions. The similar method you apply and obtain a, b, c values and substitute here, right? 1 by 40, L inverse of 1 by s plus 2, b is minus 1 by 15 and c is this one, right? 24 like this. Now the inverse Laplace transform of 1 by s plus 2 is e to the power of minus 2. 1 by s minus 3 e to the power of 3t. 1 by 24 s minus 6 e to the power of 60. Here 1 by s plus 2 e to the power of minus 2t. So e to the power of minus 2t, here also e to the power of minus 2t, take out here. So 1 by 40 plus 1 is 41 by 40 e to the power of minus 2t. Minus 1 by 15, right, e to the power of 3t. 1 by 24 e to the power of 60. This is the solution of the given differential equation by applying inverse or Laplace transform, not only inverse, applying Laplace transforms. This is the best method to solve the ordinary differential equations. Right? And next example, let's take this example. Here, y double dash minus 3y dash plus 2y equal to 4t plus e to the power of t, where y of 0 is 1, y dash of 0 is minus 1. Here y is the function of t, na? Y is the function of t, right? Because is a y depends on t, na? Here 4t time domain, na? So this is a second order, apply Laplace transform for second order derivative, right? And first order derivative, and this is zero order and like that. So inverse, sorry, Laplace transform y double dash t minus 3 Laplace transform y dash of t plus 2 Laplace transform y of t Laplace transform t. Both sides apply Laplace transform. You know the formula y double dash t Laplace transform is this: s square minus s square y bar of s into y of 0 minus y dash of 0 minus is 3 into y dash is s into y bar of s y of 0. Right? This is a formula, first order derivative formula. second order derivative formula already we discussed in previous slide. And y of t Laplace transform y bar of s. And here Laplace transform of t. What is the Laplace transform of t? A t power 1, right? So 1 factorial by s power n plus 1. So s square. 1 factorial by s square. Right? Is it right? Laplace transform is 1 by s square. Here already 4 is there, so 4 by s. E to the power of 3t Laplace transform 1 by s minus 3. Now apply these initial conditions. Y of 0 is 1, y dash of 0 is minus 1. Just you put y of 0 is 1, y dash of 0 is minus 1. Y of 0 is 1, right? Y bar of s. Now simplify this. Take out y bar of s common and simplify. Y bar of s is, right, s square minus 3s plus 2. Here minus s plus 4, the remaining terms, and send to right hand side, right? And these roots of this s square minus 3s plus 2 equal to 0. What are the roots? S square, here minus 2s minus s. Minus 2 into minus 1 is plus 2, minus 2 minus 1 is minus 3, plus 2 equal to 0. These are roots, so s common, s minus 2, here minus 1 common, s minus 2, here minus into minus 2. So roots are s minus 1 and s minus 2. These are roots, right? Now s minus 2 and s minus 1 sent to right hand side. So 4 by s square into this, and 1 by s minus 1, s minus 2 into this, and s minus 4 by this. So if you take the LCM of this function is s square, s minus 1, s minus 2, s minus 3, and this is a numerator and this is a denominator, right? So y bar of s is equal to, right, s power 4 minus 7s cube plus 13s square plus 4s minus 12 by this one s square, right? Here s 2 1 3 4 5 s power 5 now. So split into partial fractions. Inverse Laplace transform is split into partial fractions, right? This is a big fraction. So a by s, b by s square, c by s minus 1, d by s minus 2, e by s minus 3. Is it right? So now the simplifying and calculate a value is 3. After calculation, b value is 2, c value is minus 1 by 2, d value is minus 2, e value 1 by 2. Then they directly substitute here a, b, c values. So 3 inverse Laplace transform here 1 by s. Apply inverse Laplace transform both sides. 1 by s. 1 by s is Laplace transform constant is constant by s. So 1. And inverse Laplace transform 1 by s square is t, just now is. And inverse Laplace transform 1 by s minus 1 e to the power of t, 1 by s minus 2 e to the power of 2t, 1 by s minus 3 e to the power of 3t. This is the solution of given differential equation by applying Laplace transforms, right? And here one more problem is a d square x by dt square plus 9x equal to sin t. Sin t, here x of 0 is 1, x dash of 0 is minus 1. Is it right? Similar procedure just to follow. Take inverse Laplace transform both sides. Here second order derivative, here first order derivative. Now first order simply only x of t is x bar of x. Only second order next x. So Laplace transform sin t is 1 by 1 plus s square. Right? Here the conditions of x of 0 using initial conditions, x of 0 is 1. Here x of pi by 2 is minus 1. And x double dash of 0 is not given in the given function, x dash of 0 is a. Right? Here you observe here only two conditions, x of 0 is 1, right, and x dash of 0 is minus 1, right? but here x dash of 0 is not given. This is x of this is not given. This is actually finally we will get. Just to assume x of pi by 2 is minus 1 by 2, right? So x dash of 0 is assume a. X dash of 0 is assume a. So finally you would get a value also. So by substituting this, x of 0 is 1, x dash of 0 is a, x dash of 0 is a, right? Now just you take this, simplifying this, then we get and s square plus 9 is 1 and send to these functions. So s by s square plus 9, a by this and this side, taking inverse Laplace transform both sides. So inverse Laplace transform is split into partial fractions. You would get this 1 by s square plus 1 s square plus 9 is equal to, you can write this split into partial fractions. And this is directly, this is cos 3t, this is sin 3t, right? Substitute in equation number 1. So then 1 by 8 inverse Laplace transform this, 1 by 8 inverse Laplace transform this, like this. This is EA already. Now this is sin t, this is minus 1 by 8, this is sin 3t by 3, this is cos 3t, and this is sin 3t by 3, so a by 3. Now sin 1 by 8 here sin 3t and sin 3t take out here. Right? Taking t is equal to pi by 2, that is x of pi by 2 is minus 1, it is given. X of pi by 2 is minus 1. Now simplifying these conditions, so you will get a is equal to 7 by 2. Right? Finally, we will get this solution. And next is third order. Previously we discussed only first order and second order differential equation. Now this is for third order differential equation. d cube plus or minus 2d square, sorry, plus 5d equal to 0. So third order, this is a operator form. Just to write down y triple dash minus 2y double dash plus 5y dash is equal to 0. D is d is equal to d by dx now, right? So y triple dash means dqy by dx cube. So then apply Laplace transform both sides. Third order derivative, this is second order derivative, and first order derivative equal to 0 here. Homogeneous equation equal to 0. Right? Now simplify this, use these conditions, y of initial conditions, y dash of 0, y double dash of 0. Use initial conditions and solve this. So now applying initial conditions, you would get this. Y bar of s take out here, s cube here, right? Minus 2s square plus 5s minus 1. This is minus 1 equal to 0. So y bar of s is 1 by s cube minus 2s square plus 5 plus 5s here, 5s. So now s take out 1 by s square minus 2s plus 5. Is it right? Now y bar of s is equal to 1 by s into s square minus 2s plus 5. So how you find the inverse Laplace transform of this? So let's take this s square minus 2s plus 5, s square minus 2s plus 5 equal to some 0. We can't get roots. So then what we get is just rearrange this s1, s minus 1 whole square plus 2 square. Is it satisfy this? Yes. S square minus 2s plus b square 1. 1 plus 2 square is 4. So 5 satisfy. So write down s 1 by s minus 1 whole square plus 2 square into s. Right? Apply inverse Laplace transform both sides. So 1 by s minus 1 whole square plus 2 square. This is equal to e to the power of t by 2 sin t. How it is possible? The inverse Laplace transform of f bar of s, f bar of s by s, division by s formula, division by s formula here, 1 by s, na? Division by s, right? Division by s is integral 0 to f of t dt. So this is equal, this is f bar of s, this is f bar of s. So from this calculate f of t, f bar of this is this, f of t is e to the power of t sin t by 2. So integrate 0 to t e to the power of t sin t by 2 dt. Here it is in the form of e power ax sin bx formula, integration of e power ax. So what is that? E power ax by a square plus b square into a sin bx minus b cos bx. So here e power ax by a square plus b square. A sin bx, here a is equal to 1, b is equal to a sin bx minus b cos bx, and integral 0 to 2. This is a formula, right? And substitute limits. The upper limit same as this function. Lower limit, this is e power 0 is 1, sin 0 is 0. Here cos 0 is 1. So minus of minus plus 2. So this is equal to, what do we get here? Just simplify this, 1 by 5, 5 by 2 e to the power of t cos 2t. Here 1 by 10 e to the power of t sin t. That's all. This is the given difference. You know already the Laplace transform f bar of s by s is integral 0 to t. Right? This is about uh, solution of the given differential equation. Similarly, we can solve the differential equations by using Laplace transform method. So here you may take this d square y by dx square 2 dy by dx plus 5y equal to e to the power of minus t sin t, y of 0, y dash of 0 equal to minus 1. Similar procedure here also. Apply both side Laplace transform right in the Laplace transform and substitute initial conditions and simplify, you would get the solution. This is also second order, and this is also second order, x d square plus 1 into x, right? X means here this is d square x by dt square is nothing but function of t plus x of t equal to t cos 2t, t cos 2t. How you get the Laplace transform t cos 2t? So multiplication with t cos 80 t sin 80, already we discussed na? T cos 80 t sin 80. So a is equal to here, just to write a is equal to, so multiplication with t formula apply. So how you get this Laplace transform e power minus t sin t, e power minus t sin t? Apply first shifting theorem, first shifting theorem, right? What is the first shifting theorem? Already we discussed, right? So apply first shifting theorem and solve this, and this is multiplication method. And next is d square x by dt square minus 2 dx by dt plus 2x of t is equal to 0. Here x, this is x dx by dt is equal to 1 at t is equal to 0, means simply x dash of 0 is equal to 1, x of, right, x of 0 is equal to 1. This is x of 0 and x dash of 0 is only 1. It's a combined conditions are given, x of 0, x dash of 0 initial condition. Then solve the differential equation. This is the advantage of solution of ordinary differential equation by applying the Laplace transform and inverse Laplace transform. Using this inverse Laplace transform and Laplace transform method can solve highly ordered differential equations also, highly complex differential equations also. Sometimes the differential equations not solved by the ordinary methods. What is the ordinary method? complementary function plays particular integral. If maybe fails, then go to the Laplace transform and solve the differential equation applying Laplace transform method. Thank you very much.